So today, we're going to dive into a pretty epic battle that's happening right at the heart of artificial intelligence. It's all about the programming languages that actually build our AI. For years, one language has been the undisputed king. But let's just say the ground beneath the throne is starting to shake. And this is the big question, right? Is Python's time at the top almost over? I mean, this is what everyone in the AI dev community is talking about. Python is absolutely everywhere, but as AI gets bigger and hungrier for power, developers are starting to bump up against a very hard wall. And that's thrown the door wide open for some seriously powerful new challengers. Okay, so first, let's set the scene. Before we get into all the drama, you have to appreciate the current king of the castle. For the better part of a decade, Python has been the absolute, undisputed language of AI, especially when it comes to research and just trying out new ideas. And it's not hard to see why its dominance is so total. It's the main way you talk to all the big frameworks, PyTorch, TensorFlow, you name it. Its ecosystem of tools is just colossal. You can find a library for literally anything you could ever imagine. It's super easy to learn, it's fast to write, and it lets researchers go from a crazy idea to a working model incredibly fast. It won because it was just the path of least resistance. But, and this is a big but, here's where the story takes a turn. This quote just nails the tension perfectly. All the things that make Python an absolute dream in the lab, how simple and flexible it is, well, those same things can become a real liability when you're trying to serve that model to millions of people in the real world. And that's where we start to see the cracks in Python's foundation. As AI escapes the lab and goes out into the wild, developers are running like head first into this massive performance wall. It's a bottleneck that's forcing everyone to start looking around for other options. And the heart of this problem, the villain of our story, actually has a name, the Global Interpreter Lock, or the GIL. Now, to put it simply, even if you have a beast of a computer with dozens of cores, the GIL means Python can really only use one of them at a time for any heavy-duty work. It literally forces everything to get into one long single-file line. And this analogy just illustrates it perfectly. Imagine your powerful multi-core computer is this massive 16-lane superhighway. Well, the GIL is like a rickety single-lane bridge that all 16 lanes of traffic have to squeeze through one car at a time. It doesn't matter how wide your highway is, right? Your speed is totally capped by that one tiny bottleneck. And hey, this isn't just a theory. We can see it in the data. Look at this. In an experiment running a really CPU-heavy task, when they added a second thread in Python, it actually got slower. Slower. It's like all the overhead of managing that traffic jam just made things worse. But now look at Rust. It gets dramatically faster. It scales almost perfectly. So the huge takeaway here is that for some jobs, just throwing more power at Python simply doesn't work. So that brings us to our first major challenger, Rust. Now, you might not see Rust in a researcher's notebook, but it has quietly become the absolute workhorse for high-performance AI infrastructure. It's the powerful engine running behind the scenes. Let's just do a quick side-by-side. Python is interpreted, so it's kind of slow. Rust is compiled into raw machine code, so it is blazing fast. Python uses a garbage collector to manage memory, which can be unpredictable. Rust has this amazing ownership system. No garbage collector, just pure predictable speed. And of course, Python has the GIL holding it back, while Rust is free to use every single core on your machine. Oh, and it catches errors before you run your code, not when it's crashing in front of your users. And we are not talking about some small niche language here. The biggest names in AI are betting big on Rust. Meta built an entire machine learning framework called Candle in pure Rust. Hugging Face, which is kind of the center of the AI universe, uses it for its most critical parts. We're even hearing that Elon Musk's xAI is building their entire infrastructure on Rust. So yeah, it's already here, powering the tools you probably use every day. Okay, but what if you could have it all? What if you could get that raw, heavy metal performance of Rust, but without giving up the comfortable, easy-to-use syntax of Python? Well, that is the incredible promise of a brand new contender called Mojo, and it was designed from the ground up specifically for AI. Seriously, Mojo's goal is unbelievably ambitious. They're trying to give developers the familiar, friendly feel of writing Python, but with the raw, down-to-the-metal speed of a language like C or Rust. They really want to be the best of both worlds, with no compromises. So how do they pull this off? Well, for one, it's built on a much smarter compiler. But its real magic, the secret sauce, is how it handles memory. It has this incredible feature called eager destruction. Just think of it like a self-cleaning kitchen. The second you're done with a tool, it's instantly cleaned and put away. And when you're dealing with these gigantic AI models that are just gobbling up GPU memory, this is an absolute game changer. And if you want proof, just look at this chart. I mean, this is just jaw-dropping. In one benchmark, the Rust version used 10 gigabytes of memory. The Mojo version, 1.5 megabytes. That's not a typo. That's not a small improvement. That is a revolutionary, fundamentally different level of efficiency. It's just incredible. So does all this mean you should just drop Python tomorrow and switch to something else? No, not at all. The reality is actually way more interesting. The future isn't about one language winning. It's about a hybrid approach, about using the absolute best tool for the right job. Here's the new playbook. You start in Python. It's still the fastest way to experiment and build a prototype. Then you find the slow parts, the performance bottlenecks. You take just those tiny critical pieces and you rewrite them in a super fast language like Rust or Mojo. And then you just plug that supercharged code right back into your Python application. You get the best of everything: Python's development speed and Rust's execution speed. And here's why this really matters to you. The developers who can bridge this gap, the ones who can prototype in Python but then optimize for production in Rust, they are becoming incredibly valuable. They understand both sides of the coin, research and production, and that makes them the architects of the next wave of AI. So this whole thing leaves us with one final big thought. We're all here arguing about which language is the best for humans to write in. But at the same time, AI is getting shockingly good at writing code itself. So maybe, in the long run, the most valuable skill won't be fluency in any one language. Maybe it'll be a deep understanding of the system itself, knowing why a 16-lane highway gets jammed up at a single-lane bridge, no matter who or what actually built it.